All
All
set.
right, perfect.
Thank you.
Cool. Hello all, this is Dheeraj Singh. I am the CEO with Multi-Cloud for You North America and Chief Architect for the technologies. Let me start with the slogan. Today's goal is to turn data into information, information into insight, and insight into a value. This is being said by, as you see that, Carly Fiorina. Let me quickly go and talk about the multi-cloud view. So about multi-cloud view, where do we stand actually for? We deal with evangelism and the community. We try and fill the gap between the bridge between the corporate and the startup. We try and bring the real engineering out of the bunkers. When I say that real engineering, we do a lot of research and try to identify the best among from all over the world to identify the best engineers to bring the expertise and the technologies on board to talk about the new trending and all those different technologies. We try and guide the engineering community. We are into the consultancy. We deal with the different communities. We have a product. We deal with different products. We do research related work. We're basically a multi-cloud and data related stuff. That's where we stand. So let me quickly talk about where do we fit in today's world, the tech world. We provide end-to-end multi-cloud strategy. We deal with data science, and artificial intelligence. We work towards the blockchain, and we are very expert towards streaming all the engineering platforms. Let me go to the next slide to talk about what today's session is about. Today's session is working with Azure Synapse Analytics Services, which is going to be by Mr. Arshad Ali. Let me quickly tell you, give you an introduction about Mr. Arshad Ali. He's the seasoned architect with deep experience in architecting and delivering enterprise scale data platform. He's a principal architect, published author, blogger in Azure Cloud and artificial intelligence at Microsoft. He lives in Redmond, Washington, United States. You can visit his profile and the speaker's profile. As I said, let me quickly brief you about myself. I am the co-founder and chief data architect, Data Technologies. I'm an expert with data warehouse and business intelligence. I'm an ex-Oracle employee. I have many years of experience towards teaching, mentoring to the group of people and people. You can again find my profile under the Fifth Eye platform, which is the link is already being given. Without wasting another time, let me hand it over to Mr. Arshad. Arshad, the floor is all yours. Arshad, can you hear me?
Just give me a moment. Look like there is some issue on the sound side. There is some issue on the sound side. Let me fix that out for Arshad.
Can you unmute him?
Yeah, I'm unmuting him.
Yeah. While he's starting, let me just quickly give you a little more.
I'm back, Dheeraj. I'm sorry.
No,
yeah, I'm sorry. Yeah, I was not able to unmute myself. Yeah, I'm all set. You want me to start or you have?
Go ahead. I mean, I was just about to say that I'll guide you all. Once we're done with this session, we have a free certification. I'll guide you all once Arshad will announce the code to get the certification on this. The floor is yours, Arshad.
Yeah, thanks a lot, Dheeraj and Anjani, for having me here. Good morning, good afternoon, and good evening, everyone, from wherever you are dialing in. Appreciate you joining this call on Sunday evening, especially in India and people in US joining on their extended weekend. In this session, what I'm going to do is to talk about Azure Synapse Analytics. what it is and how it breaks the silos by bringing both big data, data science, and traditional data warehousing capabilities under a single umbrella. Having said that, let me go to the next slide. So this is me, Arshad Ali. I'm a principal architect, as Dheeraj just mentioned, based out in Redmond. I specialize in data platform and data analytics. For last couple of years, I have been working on greenfield and data platform migration opportunities, and I'm active in the community, technical community. I have written 200 plus technical articles and published, co-authored a book on big data analytics. So analytics and AI is the number one investment for business leaders. We all know this for last couple of years. However, we have seen that they struggle to maximize the return of investment. There was a research done by Harvard Business Review last year, and as per that report, 80% of leaders reported that they struggle to become mature user of data. The same report also states that data silos and data management are the kind of roadblocks for them to realize the full potential of this opportunity. Before we get into details of how we can capitalize on this opportunity, let's look at the different analytical system we do have today. On this slide, on the right side, what we see is business analytics. Some people call it as a business intelligence, and very recently, people have started calling it as a traditional BI. And what does it mean is basically the data warehousing kind of solution that has been built over a period of time. This solution is mainly built with the relational database engine, be it Oracle, SQL Server, or any relational database engine. Given this system has evolved in last couple of years, the performance of this kind of system is very consistent and dependable. It has proven security and privacy capabilities built into it. Though it only deals with structured data, right? So this is what we have been kind of familiar with for a very long time. However, there are certain challenges with this kind of system. And the very first one is scalability, right? So when we talk about hundreds of terabytes of data to petabytes of data, these kind of systems are not designed to kind of take care of those kind of scenario. The next one is the flexibility, right? So this kind of systems are designed with a schema on right approach, right? So every time if we have to bring in new data, there is a time needed to kind of define the whole process of the schema, building the pipeline to bring the data. So there is a good amount of time to get inside, right? So there is a lag in bringing inside in this kind of system, as well as this kind of system is only meant for working on structured data only. So that led us to kind of build another analytical system, and what we often call it as a data lake, right? So in this data lake, we can have any sorts of data coming in here without worrying about what the data is. We just simply ingest the data or land the data into data lake, and we kind of make use of data when we need to, right? So that's where the philosophy of a schema write changed to a schema on read, right? And this kind of system has been designed with the newer capabilities. Newer capability in terms of like building the machine learning and artificial model, right? So we have the libraries and technologies available in data lake space to do those kind of work, right? So having these two systems running in parallel, businesses are forced to mention these two critical system in silos. Now, if we look at how we can integrate these two systems, there are certain challenges with it. And the very first one is the security, right? So if we talk about data lake, right? So we have this data coming in here, sitting in files, and what often businesses needs are the row level security or column level security, and implementing those on file sitting in data lake is challenging. We can create views to kind of restrict the access, or kind of implement those kind of security, but creating views or creating too many views can kind of add the adds to the maintenance of those different objects, object or artifacts that you have in the data lake. The next one is the data that's coming into data lake, right? So data lake has been designed with a philosophy that whatever data is coming in, so instead of or like instead of kind of analyzing the data when it comes in, let's land it as is whatever data is coming into data lake and do the analysis only when there is a need to analyze that data, right? So with that philosophy in mind, we don't know much about the data and what the sensitivity of that data is, right? And because of that, we can't secure what we don't know, right? So that's another challenge with the data lake. And user management, right? So when we talk about data, we also would like to ensure that the data is available to the right people at right time, but it's only available to the people who have access to use it, right? So how we can ensure that data is being used by people who have been authorized to use it, right? So building that security is another challenge that we often have when we deal with integrating these two systems together. In mixed kind of environment where we have different types of workload running, right? So there will be some mission critical production jobs which are demanding and predictable, which runs on defined schedule on daily, weekly, or whatever the frequencies that we have set on. That's a one scenario, but there would be another scenario where data scientists are coming in, they are doing analysis, and they are running kind of when they are building their machine learning model, training it, those things. Those are of low priority, but again, those are important. And those kind of workload is very unpredictable. We don't know how long it's going for data scientists to finish their work, right? So those are the other kind of workload that we often see in the data lake. And we also see executive queries or queries which are being executed by or executed for executives. um, those type of queries are rare, but when that kind of queries come into data lake, those comes with high priority, right? So what we see here is different kind of workloads coming into same data lake that we have. And if we have a single cluster, it's going to be a challenge to serve all the needs of all these different types of workload. So what the solution that we have here is to kind of create multiple uh, cluster of compute resources, and each workload deals with each of those cluster, right? This is one of the potential solution here, but this has a lag, right? So if we have to bring in a new cluster, there is a lag to kind of procure the hardware, bring the cluster, set it up, and all those things takes time, right? So that's the one thing. The other thing is, because we are bringing additional um, resources, is additional compute, additional cluster, that adds to your cost, right? And it adds to the management or operational overhead that we have, right? So this is another challenge that we have. Integrate these two systems, there are certain challenges with it. And the very first one is the security, right? So if we talk about data lake, right? So we have this data coming in here, sitting in files, and what often businesses needs are the row level security or column level security, and implementing those on file sitting in data lake is challenging. We can create views to kind of restrict the access, or kind of implement those kind of security, but creating views or creating too many views can kind of the adds to the maintenance of those different objects or artifacts that you have in the data lake. The next one is the data that's coming into data lake, right? So data lake has been designed with a philosophy that whatever data is coming in, so instead of kind of analyzing the data when it comes in, let's land it as is whatever data is coming into data lake and do the analysis only when there is a need to analyze that data, right? So with that philosophy in mind, we don't know much about the data and what the sensitivity of that data is, right? And because of that, we can't secure what we don't know, right? So that's another challenge with data lake. And user management, right? So when we talk about data, we also would like to ensure that the data is available to the right people at right time, but it's only available to the people who have access to use it, right? So how we can ensure that data is being used by people who have been authorized to use it, right? So building that security is another challenge that we often have when we deal with integrating these two systems together. In mixed kind of environment where we have different types of workload running, right? So there will be some mission critical production jobs which are demanding and predictable, which runs on defined schedule on daily, weekly, or whatever frequencies that we have set on. That's a one scenario, but there would be another scenario where data scientists are coming in, they are doing analysis and they are running kind of when they are building their machine learning model, training it, those things, those are of low priority, but again, those are important. And those kind of workload is very unpredictable. We don't know how long it's going for data scientists to finish their work, right? So those are the other kind of workload that we often see in the data lake. We also see executive queries or queries which are being executed by or executed for executives. Um, those type of queries are rare, but when that kind of queries come into data lake, those comes with high priority, right? So what we see here is different kind of workloads coming into same data lake that we have. And if we have a single cluster, it's going to be a challenge to serve all the needs of all these different types of workload. So what the solution that we have here is to kind of create multiple cluster of compute resources, and each workload deals with each of those cluster, right? This is one of the potential solution here, but this has a lag, right? So if we have to bring in a new cluster, there is a lag to kind of procure the hardware, bring the cluster, set it up, and all those things takes time, right? So that's the one thing. The other thing is, because we are bringing additional um, resources, this is additional compute, additional cluster, that adds to your cost, right? And it adds to the management or operational overhead that we have, right? So this is another challenge that we have when we think about integrating these two systems. And the next one is about the challenges in lifecycle management, right? So often data scientists would need access on direct files so that they can build their data science or machine learning model on the raw data that's sitting in there without moving data between data lake and the relational engine, right? So those kind of access is another challenge. And then comes the versioning of data, whether it's a data engineer or data scientist, they would like to have some versioning control on the code that they are writing, whether it's writing in a script file or a notebook experience, right? So then they would like to have the versioning control. They they would like to have the continuous integration and deployment built into the system, so that like this process can be implemented from the beginning itself. And they would like to have the capabilities to do unit testing, integration testing, and load testing. So these are some of the challenges when we are thinking of integrating these two kind of system together. So, uh, so what we saw so far is the two worlds having their own benefit with own challenges when it comes to integrating them together. Synapse Analytics, what it does is basically it brings these two worlds together and gives you the best of both the worlds, right? So on the right side, we saw that the performance is dependable because the system has been in use for a very long time and it has matured over a period of time. So that kind of performance you can expect from the this Azure Synapse Analytics. Security is something has been built and designed for a period of time. You can get that advantage over here. At the same time, you get benefit or the ability to build a data lake, right? So Azure Synapse Analytics brings the best of both worlds together under a single umbrella. If we have to define what Azure Synapse Analytics is, so this is what you'll see in the official documentation. So Azure Synapse Analytics is a limitless analytical service, and with limitless, what we do mean is you can have as much data as you want in the system, right? So there is no kind of limit specified in terms of like petabytes or hundreds of petabytes or um, on the size of on the size of data that you want to store in the system. And it comes with unmatched time to insight. Basically, you just dump the data and start analyzing the data, right? So you don't have to spend time to define the schema before you actually start doing the analysis on data. That delivers insight from all your data. Basically, what does it mean is like whatever your data is, whether it's a structure, semi-structure, or unstructured data, you can do that analysis on the data without spending extra cycle in transforming that data. And across data warehouses and big data analytics system with blazing space speed. So what does it mean is basically you have two different types of compute engine, right? One is giving you an opportunity to kind of do big data analytics with technology like Apache Spark. Whereas on the other side, we have another technology, we call it as a SQL pool, which eventually is which actually is based on the technology that we had in past, and we call it as a SQL data warehouse. That's a relational distributed technology, and we'll talk about that. Right. So this is what Azure Synapse Analytics is. There was a research done last year by Gigaom. Gigaom is basically a research and analysis company, and they did this TPCH benchmarking comparison with different technology that's available in the market, especially in the cloud space. And what they found out is Azure Synapse Analytics is 14 times faster and it costs 94 times less than the other cloud providers. You can read about this report in the link that I have provided here. It has several other parameters and several other details, and it's good to have a look at to understand what are the options available and how they fare between each other. Having said that, let's deep dive into Azure Synapse Analytics. So what we see here is the architecture for Azure Synapse Analytics. And on the bottom of this architecture, we have the data lake, basically the lake where we land all our data. And this data lake storage is basically has been optimized for running analytical query. And this this data lake store has enterprise security built in. And what does I mean with that is we have native integration of data lake with Azure Active Directory. So you define your uh, security details here once. You define the access, you define the ACL access control list here at once, and that's going to be applicable in all the compute engines that you are going to be accessing it with, right? So on the bottom, what we see here is data lake storage, where we land all our data and define all the security rules to protect the access on that data. Next comes the set of internal feature which we use to kind of do the management, security, and monitoring of the whole platform, and we'll get into details of that. And then comes the integration layer. This is the layer or integrated platform services for managing, securing, and storing the metadata across different compute engine. And then comes the analytical engine that we can choose from, right? So based on our requirement, whether we have the unstructured data and we want to use Apache Spark big data technology to process the data, or whether we have the relational engine, relational data, or kind of flatten data into file system, and we want SQL capabilities to run and process that data. We have this choice of choosing which technology or which type of work that we want to do here as an analytical runtime. What we also have here is whether we want these computes to be dedicated or serverless, right? So in case of SQL Server, there are two variants of SQL Server runtime engine. The very first one is what we call as a dedicated, where you have dedicated resources for you to work on, right? So you can expect a consistent performance with your dedicated engine that you have. And then you have another options to kind of use serverless engine. And what does it provide is basically it lets you create a virtual data warehouse, right? So basically you have data sitting on data lake store, and then through serverless SQL engine, you just query the data without worrying about first provisioning the hardware for accessing that data, or without provisioning any compute to access that data. And we'll look at some examples of that one. And then comes a different language, the choices that you have to choose from when you are kind of writing your application, right? So whether you are data engineer or data science, you can choose either of this language to kind of process the data that's coming into the data lake. Then finally, this all experience comes under Azure Synapse Analytics Studio, and I'll walk you through what this is and what are the different capabilities. With this studio, what we get is the ability to build artificial intelligence or machine learning models, build Internet of Things application, intelligent application, and build business intelligence application. Having said that, and these are some of the internal features that we have to manage, secure, and monitor the platform. Having said that, let me quickly walk you through this service. So what we do is, like, when we are getting it started with using Azure Synapse Analytics, the first thing that we have to do here is to come to this Azure portal, create a resource, and select Azure Synapse Analytics, right? This is the one that we are going to use, right? So what you see here is Workspace's preview. Currently it's in preview. It's going GA very soon. Select this one, and then we come here, we click on create, and then we specify the different parameters for it, right? So subscription is where you want to create this resource group is kind of if you have been working on Azure, you know that it's a logical container to kind of bring all your resources under one single name. And then you specify the name for this workspace, right? So the workspace that you are creating for Synapse, region, where do you want to create this workspace, the data center region. And then you specify the default data lake storage for this Synapse workspace, right? So that's something that you specify. On the next tab, you specify the user ID password for your SQL pool if you are using SQL pool. Then there are certain details that you can provide for setting up the network configuration, right? So you can have your own virtual network and you can restrict access to Azure Synapse Analytics using that virtual network. You can control who all can kind of come and access that Azure Synapse Analytics by using firewall settings and only allowing a certain range of IP. Right, so those are the things that you can specify here over here. And finally, you click on create. It takes a couple of seconds to minutes to provision a workspace for you. I'm not going to do that. I have that already created to save on time. Once you have this Synapse workspace created, this is how it would look like, right? So you come here on the workspace, and what you see here is the different compute or analytical engine that we have, right? So you'll see one heading for SQL pool, one for Apache Spark pool, right? So I have a couple of this created. That's what you see. In your case, you might not see them when you are starting it. And what you can do here is create the additional pool, right? So for example, say I want to create Apache Spark pool here. I can come click on this and then specify the name of the pool, then specify the size that I want to I want worker nodes and driver nodes to have in the cluster, and then whether I want auto scaling of the cluster to be there or not. If that is the configuration that you want to specify, you can say auto scale is enabled, and then you can specify minimum number of node and maximum number of node, right? If you disable it, then it's going to be the fixed number of node in that cluster, right? So there is no auto scaling if you disable it, right? So that is something that you can change, right? On the next one, you can choose from the Apache Spark version. For now, we have 2.4. 3.0 is coming very soon. So you can choose from version, and then you can specify the number of minutes that it has to wait if there is no activity between that amount of time or during that amount of time. It's going to shut down your cluster to save the cost for you, right? So that auto pause setting is something that you can specify over here. Then, given the nature of a Spark, right? So Spark is extensible platform, right? So there are certain set of libraries which comes with a Spark already, and you can extend the capabilities of a Spark by bringing your own library or bringing libraries from PyPy, right? So you can, if you are working on something which is not available as part of the base image, you can bring additional libraries to extend that capabilities. And you can do that by kind of specifying what all library you want to be installed on the Spark cluster. You can note down into a notebook, upload that notebook here, and Synapse will take care of installing those libraries when it's setting up cluster for you when you are executing your first command. So it's all transparent. You don't have to worry about installing by yourself. Synapse takes care of all those things. So this is how you create the Spark pool. Let's go back again. And this is to create the dedicated SQL pool. So this is basically you create the SQL compute engine. Again, you specify the name, you specify the size or kind of performance level for your dedicated pool, and then you create that, right? So this is how we create the different types of compute in Synapse Studio. So this is one experience on the portal. Now, if you go here, you can click on Azure Synapse Studio. This is what I was talking about in my last slide, where you have all the features to start doing your core work, right? So if you click on this, it takes you to this Synapse Studio. And what you see here is there are multiple options here, right? So we have data, develop, integrate, monitor, and manage. Data is basically where you'll see all the databases that has been
And
created across.
and I would like to add one thing here, which was my personal experience when I actually work on the Synapse Analytics the first time. that I personally got confused when I saw it first time with Data Factory. So Data Factory is completely different than the Synapse Studio. Is much advanced, and there's a lot of other integration which is available now. So that is one thing which is fantastic, and thank you Arshad for guiding us here on this nice platform.
Yeah, yeah. Thanks, Anjani. So basically on the data tab, what we see here is the different databases that has been created across three compute engines that we just talked about. So there are two types of compute engine under SQL, dedicated and serverless. And then we have Apache Spark compute engine, right? So all the databases that has been created, you'll see over here, right? So these are all the Spark databases. These are all, this is my dedicated database. These are all like serverless databases. So this is what you see over here. You can start exploring those databases from here, right? So you can kind of click on this, go here, and you'll see the tables which are existing on those databases, right? So those are the things that you can explore here. The next one is linked, right? So at this place, what you see here is the list of linked resources. So if you remember when we were creating the Azure Synapse um, workspace, we specified a default storage location or default data lake. But that's not only the options do we have here, right? So we can add additional data lake store or blob storage to Synapses Studio to bring the data from other data storage, right? So we can have those things. So what we see here is the list of uh, storage that we have. So the primary one is the default one. That is what you see here. And the secondary is something that you can keep on adding additional storage account if you want to bring the data from other storage and do the analysis over here. The good part here is like you can click on this and let me show you some of the features before I go and talk about the rest of the tabs, right? So if I come here, let's say this is my data folder. I have all the data landing into my data folder. Raw is the raw zone where I have my all raw data landing in. And let's say I have this Parquet demo as another folder where I have different types of data sitting in here, right? So I have holiday data, taxi data. So let's go here in the holiday data folder. And what we see here is the list of Parquet file. So the good part here is the experience that you have. You simply right click on this and you say, I want to kind of analyze this data right away, right? So instead of going and trying to infer how to analyze that data, this gives you nice experience of analyzing it immediately, right? So you have option of accessing this data using SQL statement with the serverless engine that we have, or we can use notebook experience to load the data into data frame, a Spark data frame, and use it from there on, right? So let me kind of use both experience and show you. Let me click on this load to data frame. Basically, once I do this, this gives you a sample of the code, the Spark code, and this is the notebook experience. You can add as many as code here in this notebook experience. And before we execute this code, what we have to do is select the Spark pool where we will be executing this code. So let me select this one and let me hit it to run it, right? So while this is running, because I'm running this command for the very first time, it's going to create a Spark instance for me. Basically, behind the scene, you can say it's creating a cluster for us and going to execute this command. This process takes roughly 2 to 3 minutes, and for the first time. Subsequent execution is going to be almost immediately, right? Because the cluster is already up. So while it's coming up, let's go back again and look at the other experience that we have. Let's click on this new SQL script, and let's say I want to kind of query this data from Parquet file with SQL, right? And what you see here is the code sample already provided to you, and when it's showing you this built-in kind of option here. Basically, it tells you that like we are going to run this command against the um, serverless compute engine we have, right? So I have another compute engine. This is my dedicated engine, which is kind of paused for now, but I'm going to execute it against serverless. And when we use serverless compute, we are only paying for amount of data that's going to be processed, right? So we are not kind of paying fixed cost for compute resources, right? So that's where you can save lots of money if you have very infrequent data analysis need, right? So you can use serverless compute engine over here. So let me execute this, and what we see here is it's going to kind of query the file and give us the result over here, right? So we have file sitting into data lake, and now we have this ability to write SQL command to query the file data from those files, right? So what we see here is basically we are reading it from one file. One moment. We are reading it from one file. You can go and you can change it to kind of specify the wild character, and then you can run it, and it's going to query the whole data to give you the result back, right? So let me kind of show you some more examples on this line. So I have this kind of sample file created. So basically what I'm going to do is run this command to query the data from a single file. And if I run this, you see this, I'm executing this command and the result is coming almost instantaneously, without any time taking for you to provision the hardware or paying for you the fixed cost for the hardware, right? So this is just querying the one file. If I go to the next command, this queries all file with this star in the wild character, and it gives you all the data, right? So this is how you see that. Then if you want to know that, okay, I have data coming in from all these files, and uh, how do I know that, like, which file has which data, right? So if we want to know the file name for each of the row, we can get that as a virtual column, and this is what you see, right? So for each of the file, this many columns are this many rows are coming in, right? So basically we are going to get the file name for each of the row coming in, and do the processing on top of that. Not only you can do the query of the data sitting on those files, you can also go ahead and create a view on those files sitting on the data lake. Again, this is going to be very handy. You don't have to kind of have the compute provision in advance. You simply go here, create a view, and this view is running on this location and getting all the Parquet file and going to give you the data, right? So if I go ahead, let me see if the view is already created. Right, so view is already created. If I go ahead and I execute, I'll be able to see the data coming in here, right? So I can simply access the view. Instead of specifying this whole detail of where the data is, you can create a view, give it to your end user or business user, and business user would not know this location detail and everything. So you are kind of hiding all those details from the business user or kind of your end user, making it simple for them to only query the data, right? So this is how it works. And this is one experience that we have in Synapse Studio, where we are writing this script file. But many of us are uh, coming from a background where we use different tools to access it from client side, right? So for example, say many of us might have already used SQL Server Management Studio, right? So you can run the same command from management to studio as well, right? So there are different tools based on your preference. You can, if you are using Azure Data Studio, you can use to run this kind of command. If you have been using management to studio, you can run it from that tool. So based on your preference, you can run it from these different options to we have, right? So for example, say this is the same command that we ran it there. If I execute it from here, it's going to give you the result here as well, right? So based on your preference, you can run it from multiple places. Now let me go back again and let's see if my Spark code is completed, and this is what you'll see. So This is my Spark code which we executed here, and what we see here is the result returned back. Uh, all right, so this is how we run the Spark code on the file sitting onto data lake store. With that, let me go back again to the slide. So what we saw, what we saw earlier today was the data warehousing system that we have been using for like almost 2 to 3 decades now, if not more than that. These kind of systems are based on based on SMP kind of methodology, and SMP is symmetric multiprocessing, right? So this kind of methodology is basically where you have a single machine and all the cores in that single machine work together to finish the job, right? So that's where you can add additional resources to that machine. You scale it up to bring additional resources to kind of make your query or processing run faster. So that's kind of scenario is called as scaling of the machine, right? But there are certain limit on how much you can add resources to a single machine. So this is symmetric multiprocessing. The next one is massively parallel processing, or called MPP, right? So this is where you have, instead of kind of scaling the machine, one single machine, what you do is basically you bring multiple machine, you basically scale it out and run your job as a distributed job across all these nodes and bring the data back as a consolidated result to end user, right? So this is where you get enormous power to kind of run your query on a large volume of data, still getting the best performance that you can expect, right? So MPP is the parallelism mechanism or methodology which is built into SQL compute that we just saw, right? So this is what runs behind SQL pool. And this is how the architecture looks like when we talk about MPP engine, right? So we have application or user connecting to the control node. So control node is where like you can think of this as a master node. And then you have multiple compute node, right? Where you distribute, or basically control node distributes the job, and each of the compute node process the data in parallel and sends back the computed result to control node, and control node consolidates the result back and sends it back to application or the user accessing it, right? So this is the master and worker node architecture, where you have one master and there are multiple worker running in parallel to process the request, and they are all accessing the data sitting on the storage location in parallel, so that like there is no bottleneck over here, and sending processing the data in distributed manner. So this is how the MPP architecture looks like, and this is applicable for both SQL dedicated pool or SQL serverless pool. This is how a serverless query works, right? So we use different tools, whether we are using SSMA or Data Studio, or we are using visualization tool like Power BI to connect to serverless compute engine, which kind of lets you build or have a logical data warehouse sitting on top of Azure storage, right? So you have files sitting on the Azure storage. You can build logical data warehouse on those file system and query it from serverless compute that we have. This is something that we just saw, so I'll quickly skip it so that we can cover the rest of the piece. Again, the one point that I would like to highlight here is for serverless architecture. or kind of on-demand way of accessing the data with SQL capabilities. There is no upfront infrastructure needed here. There is no upfront cost here, and there is no resource reservation in advance. And with that, you save lots of money on cost, especially when you have infrequent data query requirement. You only pay for query execution per terabytes of data processed. The next one is the options to use Apache Spark, right? So we saw we can use 2.4 at this point of time. 3.2 is coming very soon. Um, if we talk about Apache Spark, right? So there are certain, although as a technology it has evolved a lot, but open source Spark doesn't have the enterprise level feature that you would need to build an enterprise application. And what I mean by that is basically the very first thing that comes to mind is the security, right? So you need to have integrated security with your enterprise security that you have. And what Synapse does is basically it has taken the open source Spark and built those enterprise capabilities on that open source Spark. So basically what does it mean is it's using open source so that you are not locked into Synapse. You can still bring Spark code from anywhere else and run it in Synapse, or take Spark code from Synapse and run it in anywhere on a Spark. So you are not locked in from that perspective. From the other perspective is you get additional capabilities as enterprise feature, right? So it has native integration with Azure Active Directory, so you have single sign-on when you are using Apache Spark. It has integrated metadata. So what it means that if you create a Spark table, you can access that Spark table using SQL statement in from serverless engine that we have, right? Or vice versa. You can create a serverless table in serverless compute, and you can access it in Spark, right? Provisioning is simplified. We just saw that like how easy to go and just specify a couple of parameters, and you have your Spark cluster with those configurations set up for you in 2 to 3 minutes time. The notebook experience is amazing. Like if you have not experienced it, there are several features that's built into that notebook experience. And the recent one is the native integration with GitHub. This feature was announced last week. So basically, you create a notebook. Whatever changes that you are doing, your changes are getting committed to whatever repo that you have set it up, whether it's a GitHub or Azure DevOps. You have that version control being maintained. And the use cases where you will be using Synapse Spark is basically when you have data preparation, data engineering, or ETL related work that you want to do. You can use the Spark for those kind of use cases. You can use Spark to build machine learning models. So there are libraries already built into the platform, or basically it comes with the base image, but you can bring additional libraries. So for example, say you want to use scikit-learn, you can kind of set up the configuration to install scikit-learn when the cluster comes up, and Synapse will take care of installing that library for you. And you can also bring additional library that you want to install on your Spark cluster. Uh, it has faster start, as we saw, like it takes 2 to 3 minutes maximum to kind of bring the cluster up. We can set up auto scale and auto scale up or a scale down based on how much is the load running on that pool. We can set up auto pause if there is no queries being run on the cluster. Shut it down. That is the setting that we can specify, and with that, once the cluster is paused or shut it down, all the compute resources are released, and you are not paying for compute resources at that time. You only pay for storage, which is very nominal anyway. And then again, we have multiple choice here when we come to choose the language that you want to write our application in. this is what we just saw, right? So this is the studio, Azure Synapse Studio. Data portion is what we just looked at. Develop is basically where we kind of write your code, where you can either write your code in SQL, you can write your code in a notebook experience with different programming language, Scala, Python. You can use those languages to build notebook. Data flow is what Anthony was just talking about, right? So what Synapse does is like we have these two types of compute engines to kind of process two different types of workload under a single umbrella. What we also have here is the native integration of uh, Azure Data Factory, and this is being called as a pipeline in the context of Synapse. And what does it mean is basically once you have your different component of data processing is built, you want to orchestrate this as a pipeline, right? So you can create a pipeline, data processing pipeline, um, in Synapse Studio itself, so you don't have to go out and use data factory separately. You can build that pipeline in the Synapse Studio itself, right? So what you can do here is like you can come to orchestrate tab on this Synapse Studio, and you can build whole like whole pipeline, whole data processing pipeline or ETL packages that you have been building so far in the Synapse Studio itself, right? So that's another advantage apart from the compute engines that we just saw. And then the monitor tab is where you will be monitoring all your workload running in Synapse Studio, whether it's a SQL workload or Spark workload or pipeline that you have set it up to run on undefined frequency, or you are running it on demand. So all sorts of monitoring is something that you can look at under the monitor tab. And manage is where like you manage the different resources that you have in your Synapse Studio, right? So this is what we have. And coming to the different tools, right? So we briefly talked about the tools that we can use, right? So we can of course use browser-based experience, the Synapse Studio to kind of write all our code. If we are comfortable using client tools, we can use these different tool options that we have available, right? So we can use Visual Studio data tools to create a database project to kind of use that into CI/CD process. We can use Azure Data Studio, which is kind of cross-platform tool to cross-platform client tool to kind of connect to your Synapse workspace and work on that. It can connect to different other databases, but we are talking in context of Synapse. So you can connect to Synapse, you can run it against dedicated pool or SQL pool from here, and then we can use SQL Server Management Studio to run that query. If you are a developer and use Visual Studio, you can use Visual Studio Code to write those application, and you get the same experience here as well. Right? So IntelliSense and all those things will be available here as well. Then for CI/CD, right? So as I was saying, right? So this feature was announced last week. We now have native integration of Synapse Studio with different type of repo that we have, right? So whether it's Azure DevOps, GitHub, or Git, you can connect it with that, and you can set up your CI/CD process with that. The last thing that I would like to talk about is the Azure Synapse link. So this is the newest innovation that has come as part of Synapse Studio, and what this does is basically it breaks down the barrier that has long existed between operational and analytical system. And what does it mean is basically what we generally do when we build an analytical system. We build the ETL pipeline to bring the data from different sources into a central repository and do analytics from that data store, right? So we have some development time involved to build the pipe ETLs packages, and then we have time involved or the latency involved to bring the data from different sources into data store, or basically the data warehouse. With Azure Synapse Link, you no longer need to bring that data and build the ETL pipeline. Basically, um, what we can do is we can simply query the data from the operational store, and this brings us the capabilities called STAP, hybrid transactional analytical processing. Right. So basically, you just enable that feature on your relational or operational database, and then Azure Synapse is going to query the data as you write your application. So there is no need to write your ETL package. There will not be any performance impact on your transactional system, and the data is going to be almost in real times when you are accessing it. Right. And how does it work is basically this is one example with Cosmos DB. So Synapse Link for Cosmos DB was the first to launch. You can expect to have some other support for supporting other type of databases. So let's talk about this one first. So what you see here is, like, if you have worked on Cosmos DB, you see this is the transactional store where the data is stored as row for each of the transaction. When you enable this feature, what Synapse does is it creates an analytical store, which is kind of a columnar storage, and automatically starts syncing the data from transactional store to analytical store. On the on the Synapse side, you use any of this tool, any of this different compute engine, and connect to Cosmos DB, and it queries the data from analytical store. So there are two benefits that we see over here. The very first one is the performance is going to be much faster for your analytical query, because we are querying the column store data from here on this analytical store, and there will not be any impact on the transactional store. So all your queries are hitting analytical store. It's not going to transactional store. So your transactional store will not have any performance impact. Right. So this is how you can minimize the impact on transactional store and query the data from analytical store. So this is already available for Azure's Cosmos DB. You can immediately access it, and this is one of the best work that has been done in this space. So you should, if you have not already explored it, you should explore this option, right? So you just have to enable this feature, and it takes care of for you for you internally, right? So it's all behind the scene. You don't have to kind of spend time to build anything to set this up. Having said that, we are almost 2 minutes over time. I'll open the floor for any question anyone has.
Yes, I'm trying to unmute the mic for people who want to ask question. If you can ping me, I will unmute your mic. Just ping me or raise your hand. Best is ping us. I have unmuted everyone. So anyone have any question? You can ask now.
I had a quick question. This is Dheeraj Singh again, Arshad. One of my client, one of our client basically are trying to do a parallel processing for concurrent parallel processing, and they're using Redshift, and they have over 10,000 of the users which concurrently fire queries, and they're having a lot of issues while querying the data in there. So can you throw a little bit on that side, how Synapse manages that thing?
Um, I'm not sure if I understood. So you're saying like you have this challenges with Redshift?
So we have more than 12,000 users who concurrently fire the query, like a parallelism which you just mentioned. They do have the auto parallelism, like auto scale up option, but still of course it's very costly. But I'm not going towards the cost side. But is there when you try and compare with Redshift over 10,000, have you come across with that that situation where you have over 10,000 of a user and they're parallelly querying and the performance is not the bottleneck?
Well, again, I would say like yes, for dedicated we have some limit on in terms of how many concurrent user can run the queries at one point of time, and that varies with the size of the underlying infrastructure that you have, or basically the performance level that you have set it up. So that is for dedicated SQL pool. But for if you have that data already available and you want to use like serverless architecture, I don't think there is any limit set for that. So again, I would say like it's better to get into details to understand what their use case is, and if it meets the use case is being satisfied with serverless, let them use serverless, pay for what they are accessing, and they have the access on the data.
Yeah.
Mhm.
Thanks.
So that is one option. The other option is like if I'm not sure what these users are, if they are running SQL command or they are kind of users who are writing data engineering job in Python or something else. So they
It's
might
a
consider.
mixture of that, but
Yeah,
after
yeah,
30% of the load, it queues up. Instead of running it parallelly, it queues up.
yeah. Yes, yes. So that is where like we can so the options that we have, right? So if it had been before Synapse, yes, we had this challenge, but given the advancement that we have come up with and even the number of concurrent users growing rapidly, um, I don't see that as a challenge any longer, right? So we have way to kind of handle those scenarios and take care of that.
Interesting. Yeah, thanks.
Hey, hi, Pramod here. So, Arshad, just I had a question like the Synapse integrator you are talking about, right? So, is there any other integrators like, where, for our data which we have in MongoDB and we want to dump it directly here and then get the analytics results? Can it be done that way?
You mean Synapse link for Cosmos DB? You are looking for MongoDB experience for the same one?
Yeah, so instead of Cosmos, right, I will have Mongo there, and the link, the Synapse link will where the we'll have our data dumped and the machine learning or whether whatever the analytics which we want to run here, we will hit that and get the results. Can it be done that way?
No, so at least not at this point of time. I'm not sure about the future roadmap, but see, the thing here is like when we enable this feature, it's going to create an analytical store internally and then start syncing the data from transactional store to analytical store, right? And
Okay,
this is something we can do only if the service is Azure service, in this case Azure Cosmos DB. If you have
okay,
a MongoDB running on premises, we would not have that control to go and set up analytical store and set up the sync process, right? So at least this is not available right now. But for now, what I know is this is for Cosmos DB, and we are kind of working to bring this same capabilities for other services in Azure. Other services
okay.
like relational databases services in Azure. If it is Azure service, you can like expect to have some sort of support. But if it is on-premises source system, it might not be, at least in the near future. Mhm.
Hi,
Okay.
Arshad.
Yeah.
Hi, Arshad. This is Rick. I'm calling from the UK. First of all, thank you very much for those slides. Really a lot of information there. I'm sure everyone learned something new today. It was really good to watch all of those. Can I just ask you one key question, please?
Before that, adding to introducing Rick. So Rick is the co-founder and CEO of UK Multi-Cloud for you, and he's also a data architect. He has been for his life working in the data world. So yeah, it's great connecting to you, Rick, and also.
Yeah.
Okay, thank you, Anjani. Okay, so Arshad, one of the biggest challenges we face here in the UK is that when we are trying to build a new data warehouse solution for our clients, we're looking at Azure Synapse Analytics versus solutions within AWS, such as AWS Redshift. And what I would like to ask you is what you would consider the main advantages of going down the Azure Synapse route are.
Well, again, it varies from scenario to scenario. There are several
Sure.
things that that it signs on, right? So I just talked about, right? So there are multiple compute engines to choose from for taking care of different scenario. Uh, and let me kind of go back here, right? So give me a moment, please. Let me go here. This is very interesting paper. I would suggest to read it. This will give you a very good idea. Yeah. Yeah, so Ziga is this a kind of research and analysis company. They produced this result last year, right? They have done this comparison across different compute engine that is being offered on different cloud platform. I would suggest to read this. This has lots of detail, but to kind of answer your question, in summary, the very first thing, price and performance comparison, right? That is where you get most of the benefit that you get with Azure Synapse Analytics. That's the one thing. The other thing is the performance. Performance is significantly faster in Synapse Analytics, and that has been shown with the TPCH benchmark. That's the second thing. The third thing is the integrated experience that we have here in Synapse Analytics, right? So the integrated native integration with Azure Active Directory for single sign-on, or integration with different types of compute under a single umbrella, right? So based on your requirement, you can choose SQL based computing, or you can use Spark based computing. So that integrated and unified platform is the unique experience that you have with Synapse Analytics. So that's the third point. So these are some of the points that I have in mind for now, but you can get more details
Okay.
in this paper. Yeah.
Thank you. Thank you
Hey,
very much.
Arshad,
That was very useful.
sorry to interrupt, Arshad. What is TPCH full form?
So TPACH is basically like it's an industry benchmark. So they have a set of queries which I think it's there is a consortium they have come up with this set of queries, analytical queries, and they have a set of they have a data, right? And they take the same data, they take the same queries and run it on a multiple platform just to see what the performance is, right? So that they know that the data that they are running, it's the same across all the platform. Queries that they are running, it's the same across all the platform.
Okay.
Mhm. So that's an industry benchmark for kind of comparing the comparison between different platform, basically.
Cool. Sir?
All right. So thank you everyone for joining. It has been nice experience. Hope you all learned something new today. And yes.
And one more
again,
question is there. One more question is there. Someone is asking that other than Cosmos, you will need a ETL to again import the data to Synapse. And obviously, yes, right? So anyway, like either he will have to use the Synapse Studio, or like the link service would not work, right?
no. Link service is different. Okay, let me go
Sorry,
here.
sorry. I misspelled it. Obviously, I didn't mean it. It's the link
Yeah.
that you were talking about, direct
Azure
connect.
Synapse links. Azure Synapse link is currently available for Cosmos DB.
Cosmos,
But yeah, we are working to kind of lighten up this capabilities for other services. So you can expect to have that coming in future. So that's the one thing. For now, if you want to bring data from say other sources like say on-premises sources or IoT sources, you can have that ingestion coming. You can build the ingestion coming to data lake store. Once the data lands into data lake store, then you can use the compute engine that we have here to process it based on whether want to use SQL based or Spark based. You can use either of those to do the processing. Does that answer your question?
Looks like, yeah, I think.
Yeah. Yeah. So one last thing that I would suggest here is if you have not already done that, there is a kind of a digital event on December 3rd. It's from 9 a.m. to 10:30 a.m. Pacific. This is going to be,
if you can ping the event link on this,
yeah,
or you
I'm
can say
going,
obviously, or just send me the link. What I will do is I will update on this event page which is there, so everything would be there, and that would be much better for user to everyone
yeah,
to see.
yeah. So this event is going to be on December 3rd. This is going to be led by our CEO, Satya, and you'll hear some of the innovation that we are working and have been doing. Along with that, you'll also hear some of the announcements that's coming on in this space, data and analytics space. So I would highly suggest to watch this when if you can.
Yeah.
It'll help us. Yeah, definitely.
Yeah.
Interesting. Thank you so much, Arshad. It was really amazing session. I mean, this interaction was phenomenal. Let me quickly walk everyone through that how they can claim their certificate. Let me share my screen. Let me know when you see my screen. Do you see my screen?
Yeah.
All right. So I just went on fifthir.com. There's an event. I clicked on. So go to the
And
event.
and there are multiple future events that's coming. You can join, and they are like from different
That's
experts, some on
correct.
private link, on multiple things. Yeah.
Just to
So
add,
go on.
every Saturday, Sunday, we try and make it completely free and very innovative, different sessions, which helps you in your career, which helps you to understand different technologies and come on an edge of the new technologies. So when you hover over the at the events, you will find the RSVP now. Click on that. It'll take you to the this page where you have to sign up. All you gotta do, I just put my details in there. Put there all the details. Click on term and condition, accept that, and click next. Submit it. It'll take you to the page where the whole session is going on. So if you scroll it over down, you'll find multiple different links. You can, of course, later on you can try clicking on any of these free quiz to take. But currently, to get the certification, you got to click on this. When you click on this, it'll ask you to fill up your information. Do the same thing what you've already done in the previous slide. Click on next.
And the code is ASDWH, which is all in caps. A for Apple, S for Synapse, D for data, W warehouse. I have also pinged in, and I'm again pinging it. ASDWH. Yeah.
That's the code. All you gotta do is to put the code, click on next, and then submit it. That's it. You'll get that in your email.
Yeah.
Go ahead.
And whatever the message that also is saying, if you,
sir, can you please say it again?
I pinged it also. ASDWH. ASDWH is there also in the chat box. A for Apple, S for Synapse, D for data, W for where, H for house. So ASDWH. And once you get that, what you have to do is like you have to come into your dashboard page. Dheeraj, if you can go on the dashboard page, just click the link which is just beside this form. The another one that you open. There are two in page open. No. So just another tab which is after your WhatsApp. Yeah, that one. So here again on that certificate link, you will see your certificate. And even at the account, if you go at the top account, Dheeraj, at the account section at the top, the man is there at the end. At the end, account. Yeah, account. No, just before that. That one, yeah. So my courses, my certificate, all your past certificate, all your past courses, if your email is tagged, everything would be here. So if you go on the certificate, you will be able to see all your certificates. See, Dheeraj has tried and tested 2 certificates. It's there. You can do direct download and then share it to anywhere. This is LinkedIn shareable, connectable. So if you just click it, so it will show up. Just click it. So you'll see the certificate has come up, and all your past certificates. Yeah. it always remains here. So it's not going to be deleted or anything. It's going to be connected on the blockchain with the time. So it's like a claim. It has a digital signature. It has everything in the background. Share it on the LinkedIn directly, and you can attach it on the LinkedIn the way you attach your LinkedIn certificate or anything. So it's almost gives you a nice credit with all the logo and everything that comes up. Yeah. And the biggest thing is from the engineers who actually build the system. So that's the best benefit here. Yeah. So we hope you have enjoyed the session, and do keep
Are
connecting
the
with us.
slides available for us?
So everything would be there. Whatever is there on this link that Dheeraj saw, right? So I have already pinged it, and if you're able to access the chat window, try to navigate to this chat window.
Yeah,
And
thank
all
you.
the
I see that.
yeah. So all the content would be there. Maybe it takes time. Again, we have to curate this, review it from the legal perspective and everything. Once a speaker agrees and all, but it will get attached. Everything will get attached here. Still, there are ebooks. There are a lot of documents that we have attached on this page. So if you go there, you'll see even whatever Arshad was talking about the event and the session, we'll attach that. Everything will keep that there.
Makes sense. Thank you.
Thank you.
Cool. Thank you all.
Yeah. Thank you, Arshad.
Thank you so much,
Have a good
Arshad.
day. Yes, thank you.
Thank you, everybody.
Thank
Bye.
you. Bye. Bye.
Bye.